Okay, now we're going to show our last collection of new true formulas, at least for a very, very, very long while. Now, to show these formulas are true, really all we're going to do is apply expansion or FOIL, if you'd like to call it that. And that was a procedure we had previously shown to be valid. In fact, we reviewed it right at the beginning of slides, and it was reviewed from a previous class day. So these last collection of formulas tend to be actually very nice. All you really have to do is apply a very common, tried and true algebra procedure that I think students tend to like, which is just to expand what you have. So why is a plus b times a minus b equal to a squared minus b squared true? So unlike so many of the other things where we had to draw diagrams and this and that, now we have a foundation with so many other true formulas, we're going to rely on a true formula we have. Namely, we're just going to FOIL. Take the left side and expand it out. And you get a squared minus ab plus ab minus b squared. The two inner terms, you have a negative ab, you have a positive ab. Those will simplify to a 0. So you're left with a squared minus b squared. Done. That's what's on the right side. So just to recap here, what happened is we had what was on the left side. We just started with that. Let me step back here. Took what was on the left side, FOIL this out, and then collect like terms or simplify, and you have a cubed minus b cubed, which is the thing on the right. Here's another one. Why is a plus b quantity squared equal to a squared plus 2ab plus b squared true? Well, take the thing on the left, write out what squaring means, so a plus b times itself, and then expand that out using FOIL, collect like terms in the middle, and you have a squared plus 2ab plus b squared. That's what's on the right side. So is the formula a plus b quantity squared equal to a squared plus b squared true or false? Explain why. This formula is false. You can plug in almost any combination of numbers to show this. I'm going to use a equals 1 and b equals 3, and the left side will become 1 plus 3 quantity squared. This is not the time to try to distribute the square. That's what we're trying to discuss right now, if that's valid or not. So now that numbers have been plugged in for all the variables and there's no more variables, you should simplify using the order of operations, right? So focus on what's in parentheses. You have a 4, there's still a square, so 4 squared will be 16. On the right side, a squared plus b squared will be 1 squared plus 3 squared, in other words, 1 plus 9, which is 10. The left sides and right sides weren't equal. We had 16, we have 10, so therefore this formula is false. Now, just this one example of why this formula is false is telling us why we can't trust this formula. This formula lied to us once, and so we're just not going to trust it at all. Now, just please remember that for false formulas, you must always plug in numbers. Just no exception to this for false formulas, okay? For this question, for instance, sometimes people will compare the left side of this formula to the previous slide where we looked at a true formula. And some people will say, oh, this formula is false because the right side should have said a squared plus 2ab plus b squared. Well, instead of comparing it to something else and talking about what maybe it should have said, for a false formula, the whole point is to really provide an argument that would really help out a peer who might be trying to use this false formula. And it doesn't really convince somebody that a formula that they're using, a false formula that they shouldn't be using, it doesn't really convince somebody that that formula is false just by saying, no, 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 you should just do this instead, right? That doesn't convince somebody that, first of all, the thing they're doing doesn't work. So that's why I really am saying for false formulas, you just need to plug in numbers. Okay? I mean, for instance, you might say, well, why not? Why can't I just argue about what the right side should have said? Um, well, just it doesn't work out this way. I mean, it requires more argument, but why couldn't it maybe coincidentally, maybe have been that a squared plus 2ab plus b squared and a squared plus b squared, while they look different, maybe they were actually the same. And that's just too much of an extra argument to go into. So the whole, instead of doing that, just plug in numbers for the false formulas. So in summary, a plus b quantity squared equals a squared plus 2ab plus b squared was shown true by relying on FOIL, which is a procedure that we showed was valid earlier, while a plus b quantity squared equals a squared plus b squared was shown false by plugging in numbers, not by comparing this to the true formula's right side for what should have been. Um, you should perhaps try some of these out, these formulas that are in the boxes. Just the way the question is worded is meant more for like a future quiz or exam, but these formulas all happen to be true, and they can all be shown using a FOIL or expand. And you should try one or more of these and then click to see the key and see that things are going okay for you first before going on to the next part.